Hi everyone, my name is Ethan Moyer. I'm the current president of Drexel AI. It is June 22nd, 3 p.m. about Eastern Standard Time. 2 minutes till 3 actually. So we'll wait for people to join. I'll just be here chilling. This is our first meeting of the summer term. And I just realized that I probably had a typo in the email I sent out to everybody. May have said spring term by accident. I'm trying to go back in time. Yeah, I'm trying to go back in time. I said spring GBM, but it's the summer GBM. Anyway, today will just be introductory to the club, what we're all about. The former president Yit usually gives a nice presentation at the start of the term, but I'm going to save that for fall term actually. About AI and machine learning in general. I'm going to assume that most people joining Drexel AI are past members from the fall, winter, and spring terms. But we'll get a survey of who's doing what and come up with some project ideas for this term, because our goal each term is to hi Andy. Hey Andy. Hey Molly. How you doing?
I'm fine. How are you?
Good. Where are you?
I'm at the lab. So I'm working at the EESI lab at Drexel.
Okay. What project are you doing now?
Protein function classification based
Really?
on, yeah. But it's not based on the structure, it's based on the amino acid sequences.
Oh, okay. That's a simpler problem. Cool. How's that going?
Oh, hello. Just connected the audio.
Yeah.
I'm
Hi.
doing good. Haven't changed since the last minute.
Yeah. Hi, Alicia.
Hey.
Cool. Well, the gang's all here. I started recording like 2 minutes before, and I gave like an introduction for the video. But yeah, welcome to summer term. I think in my email I accidentally said spring term. I'm trying to go back in time or something. But yeah, it's summer term, and I don't exactly have a project ideas in mind. I was kind of hoping that we'd discuss people's interests. And Adam's here. Hi, Adam.
Hey everyone, how's it going?
Good. How are you? Yeah, like I was saying, we could discuss everyone's interests and maybe see if we could kind of think of what we can do. So I guess the new member here is Andy, and I think we can just go around and introduce ourselves. Most of us, well, it's just me, Adam, and Alicia who are on the e-board. But I'll start. So my name is Ethan Moyer. I'm finishing up my second year at Drexel as a biomedical engineering student. I have interests in AI, bioinformatics, machine learning, those fields. I've done research through the VIB program with Professor Doss. I'm currently working on my co-op at Moberg Analytics as a clinical informatics engineer, and I have experience in genomics as well at the Children's Hospital at a bioinformatics lab there. And I love machine learning, so that's kind of why I took up this opportunity to, be the president for this coming year. So, Alicia, would you like to go?
Sure. I'm Alicia. I'm the vice president of Drexel AI. I'm also finishing up my second year. I'm a computer engineering major, minoring in math and neuroscience. Currently, my research interests are neuromorphic computing, machine learning, sparse coding, and recently bioinformatics. I don't know like in what area, but recently like bioinformatics has just interested me a little bit. I did research at VIP, same thing with Ethan with Dr. Anoop Das. with his neuromorphic computing project. And also for my co-op, this past fall winter, I worked at Penn State doing machine learning for time series classification and anomaly detection.
Alicia, you actually reached out to my PI at the Children's Hospital.
Yeah, I did not know you were a part of that either.
Yeah, you could have asked me if you had any questions. I know we're looking for active members.
Oh, cool. Okay, I'll actually after the meeting then.
Yeah, cool. Yeah, you want to call on somebody?
Oh, Adam, do you want to go?
Yeah, sure. I'm Adam. My interests in AI are mainly in AI safety. So making sure that we build AI that doesn't destroy the world, basically. What else are we saying?
What are you studying? What year are you?
Oh, I'm in my third year. I'm just finishing up my third year, and I'm studying math as a minor in computer science.
Cool. And then one comment, Adam, that I just thought of is whenever we write a paper, it might be a good idea for you to include a section on the safety of and the deployability of whatever we create, because that might be geared towards your specific interests.
True. Yeah.
Yeah. Cool. Would you like to call on somebody?
Yeah. Isamu, have you gone yet?
Oh, no. I'm Isamu. I'm a computer science sophomore student, and I guess I like reinforcement learning the most. It's a fun field, like making machines play games with each other. Yeah.
Have you done a lot of projects in reinforcement learning?
I did one, but for
Okay.
that one, I've been working on it since 2018 or something.
What software did you use for that?
OpenAI provides reinforcement learning baselines. So basically, I made my own game and used those baselines to just play against each other, and it's quite fun. Yeah. Yeah. Honestly, it's still stupid, but quite fun.
I'll go ahead before you call on somebody. I'll read Andy. So Andy Nguyen, he's computer science, and he's a freshman on summer vacation, so he'll have a lot of time this quarter for Drexel AI, which is good news. Osama, you can call on somebody.
Oh, okay, then maybe Stefan.
All right, hey, I'm Stefan. I'm a computer science major in my second year, just finishing up. Yeah, I just love AI. I have an interest in just understanding processes of learning, figuring out how the brain learns, for example. So I also love neuromorphic computing. And currently I'm on co-op with Professor Noob Das doing spiky neural networks.
Cool.
Alright, guess Hung?
Yeah, sure. So my name is Ansh Talakia, majoring in computer science, and I'm a freshman. Also, right now I'm just currently focusing on the basics of machine learning, clustering, regression, and stuff. And I've been watching some YouTube videos, particularly from ZenDex, and I'm right now halfway through the playlist. So I'm just really picking up stuff and trying my best to contribute to this company.
Cool. Welcome. You can call on somebody. Molly, would you like to go?
Sure. Yeah, so I'm Molly. I'm finishing my second year as an electrical engineering student. I previously worked with Dr. Anupdas, just like everyone. So my topics was medical image segmentation to detect brain tumors. And then I also worked on the recreation of visual experiences by analyzing fMRI data. Right now I'm on co-op working at Ecological and Evolutionary Signal Processing Lab with Dr. Gail Rosen. So what I'm doing right now is to analyze amino acid sequences to determine functions of proteins. Hangdo, you want to go next?
Yeah, thanks, Molly. So my name's Hung De. I'm currently in classes finishing off my second year. I'm also the current secretary for Drexel AI, former vice president last year. Um, right now, I'm in the second half of STAR program, working with Dr. Edward Kim, studying about sparse coding and seeing what potential it has to create some kind of universal dictionary. So yeah.
Sparse coding is a very interesting paper. Very interesting topic, and I sit in on his lectures on Tuesday, whenever he has them, with his lab.
Yeah, they're definitely.
I love it. Yeah.
Yeah, they're definitely very cool.
Yeah. So to start off, I think most of the people here are familiar with the projects we've done in the past. I'm just trying to pull them up. I could find 4 of the papers that we did in the past, but there is a 5th, and I forget what it is. But I'll probably remember eventually. I think we did 2. Yeah, we did 2 papers in the the winter term. But just as a recap for this year, we've done 5 papers, and I have 4 of them here in Overleaf. And whenever we work on things collaboratively, what we like to do is just start an Overleaf project, and then we can all work on it. So the first paper we looked at was focusing on the binary search implementation in neural network construction, neural network architecture search. So we've implemented an algorithm that can be identified in this figure, tested it on 2 different data sets, looked at what happens in an ideal case and a non-ideal case. And we took this to two conferences. The first conference happened. It was earlier this year it was the one hosted by Harvard that a couple of us went to, and many of us actually presented. And we were actually accepted, this paper was accepted to a really big conference actually in July that Yit's going to present at, called IJCNN, the International Joint Conference on Neural Networks. So this paper is done pretty well. The second paper that we did in the fall term wasn't all that good, but we thought it was pretty cool. We tried to extend this concept to, instead of like having 1 degree of freedom where we just look at the number of hidden units in a single hidden layer. If I can find a visual, we varied basically this parameter, the number of hidden units in this layer. We wanted to look at the number of hidden units in any given number of hidden layers by looking at like K completeness. And this graph kind of summarizes what we talk about when we talk about K completeness. And it's the idea that you might have something that has a large number of hidden layers or a large number of hidden units in the first hidden layer, and it can be in this continuum. And we looked at different traversal algorithms to search for the most optimal network. This paper, I think the reviewers, they thought that it was a little, I don't think they liked the figures that we had at the end. I think Yit squeezed a lot of them in here if they would load. Yeah, he squeezed a lot of them, and I don't know whether they were exactly legible. Anyway, so that was the 2. So in the fall term, we focused on binary search, and we focused on neural network search and neural network architecture optimization, which is a interesting field of machine learning and AI, but it requires kind of an understanding of neural networks. In the winter term, that's when the whole GME thing happened, and there was a huge public interest in stock markets, and I personally started investing a lot. So I've been putting money in the stock market, but in safe stocks, not the overly volatile ones. And we did 2 papers. The first paper was by Yit. He looked at LSTM in stock market prediction compared to compared to like some other algorithms. So I think it was like benchmarking against S&P 500, which is like a well-known index for our market. This one, which is not loading, we try to use the convolution function as an objective. We try to use convolution as an objective function in learning stock market patterns. And we actually did a presentation for my friend Will Leyland, who did study at Temple, and he's since transferred to Buffalo. He has a large interest in stock markets, and he talked about backtracing and how you can kind of use stock patterns to identify regions in which you invest and sell. And then spring term, we did one paper where we tried to very quickly put together a deep convolutional generative adversarial network. The deep means that you have more than one hidden layer in a neural network. Convolutional means that you rely on convolutional layers instead of dense layers. This GAN, generative adversarial network, means that you have a two-player network where you have a discriminator and a generator that operate in a zero-sum fashion, where the generator tries to outperform the discriminator, and the discriminator tries to outperform the generator. This one had only minimally successful results, which could be to blame our feature encoding that we kind of stumbled with at the beginning, which I'll take complete blame for. There are better ways to encode protein features, and Molly was actually just talking about how he's looking at protein annotation at his lab, but they're relying on the amino acid sequences instead of the 3D protein structure, which is a much easier problem, or it could still be overly complex. So in hearing what everyone is interested in, we have a lot of people, and I'm very happy with this, we have a lot of people who are interested in bioinformatics. I'm a big bioinformatics guy. That is kind of like what I do. And I think that, it's a function that a lot of us came in contact with Anoop Das, and maybe he's pointed us in that direction of bioinformatics, spiking neural networks, which I haven't done any projects on, but I find them interesting because they resemble the brain as best they can, or a lot better than conventional neural networks. And then also with like Edward Kim, he's also more of he's ML, but it shifts more towards the bioinformatics side as well. So like Drexel AI, most members here are coming back, but we want to focus on creating novel projects, trying to extend our knowledge. So I'm really open to any discussion for what we can work on this term. I think in the first term in the fall, we really didn't have a clear idea of what we're going to work on until like week 4, and then we just busted it out in the last half of that term. So this can be an ongoing discussion. I'm sure we'll talk in Slack, but I'd love to hear about any ideas that you might have. I think it's cool to start thinking about A, a topic, B, a question, and C, a method.
I think we can explore is it called ECG, EKG? It's for the heart rate estimation. It's something we mentioned last term as a potential project. And
are you talking about a point Are you talking about a point prediction? Or are you talking about?
It's for the I think the potential applications were like heart attack prediction based on the
Oh, I think he's talking about your
idea. Yeah, you mentioned something from your professor where he described it as a low-hanging fruit. I'm kind of hazy on the details.
Okay. Yeah. Let's whiteboard it. And I know I'm on a MacBook, so I don't have MS Paint. So what I think what you're referring to is like if you have some signal, some time series signal, and this can be like generalized, right? So it doesn't have to be EKG, it doesn't have to be stock predictions, it doesn't have to be EEG, it just has to be some sort of signal. You have kind of your feature set, which is right here. And then you're always trying to predict. So like if this is 50 points right here, you're trying to predict the 51st point. And if you do this for like a random set of points in a signal, this isn't difficult to do if you use some sort of LSTM model. But the problem occurs when you try to have like a sliding window. So if you move these 50 points to the right, and you use your predictive value of the 51st point in the next window, what ends up happening is like if this is the prediction, you might predict the 51st point to be here. Sorry, you might try to predict the 51st point to be here, but then as you predict and you move the sliding window, you might have something that like just like goes off, right? And there's no way. It's not easy to understand that you need to actually go toward. You're going away from what you're predicting because you're predicting on predictions. So I think the idea that there really is no good way to predict on predictions, and that's a big problem. That is a low-hanging fruit if someone can actually accurately predict this by predicting on predictions. And I think it's a math problem too, because the errors are additive. So the error that you'll get from predicting the 51st point is going to add to the error that you're going to have when you predict the 52nd point, and the 53rd point, 54th point. And it's a function of, the fact you're using predictions as features. So if there was a way to necessarily know if there was a way to kind of understand whether your prediction was, I wouldn't know. But you almost need a way to zero out those errors or make them as small as possible. Yeah. Molly, is that what you're referring to?
Yep. Yeah, that's it.
Okay. Yeah. So I know that, Alicia, you mentioned you did time series prediction. Did you ever explore this problem?
No, I didn't. But there's a paper I read for that, like there's like a GAN model that's like specialized for time series, but it's only for anomaly detection.
Okay. Do you know how it works? I mean, is that that's probably like a classification between anomaly and non-anomaly?
Yeah. I can
Okay.
try to find the paper too.
Yeah. So this, like Molly mentioned, I talked about this last term as it being a low-hanging fruit, and that's something that Ed Kim mentioned as it being a low-hanging fruit. But it's a very difficult problem because the idea is that you don't necessarily have these red points available. You're trying to predict the pink here, but you're worried that it's just going to go off in this direction and you don't know how to bring it back. Maybe this is where the whole sparse coding thing comes in, where you have an understood dictionary that would kind of say, okay, this isn't possible. You predicted this and it's not possible. So maybe the answer lies in the fact that you have an understanding of what it should look like. And that might actually be a possible method because of the fact that creating a sparse representation of the data is unsupervised. So you don't necessarily need to have those features. You don't need to necessarily have those predictions ready. Osamu, what would you see any problems in trying to implement like a sparse coding and as a way to reject this prediction that is kind of drifting?
So for sparse coding on time series, right?
Yeah.
I discussed it in mobile a bit, but like basically what sparse coding is you kind of combine bunch of like waves. So like, for example, if you have like high noise waves and like, I don't know, low frequency waves and stuff, you just combine all those to form a new way, which is the data. But one problem is that the phase difference, right? So if the wave is shifted, you need to make a new dictionary element for that. So like one approach is doing Fourier transforms and then doing it. And
would there be, so
yeah.
like, okay, but I guess, I have an idea. So when we think about, I'm going to draw a picture here and we're going to change our domain. So instead of looking at time, we're going to look at frequency. Frequency. And then there's going to be a
for frequency time. Just
yeah, frequency and magnitude. Yeah. So that you can generate this domain by using the fast Fourier transform, which effectively takes some time series signal like EEG, anything that involves in time, and it basically gets the frequency contribution. So if we're looking at like this is 0, this is 30, this is 60. We can just say that maybe the frequency contribution looks like this or something, with like a spike at 60 for the for harmonic. Would there be any kind of would there be any would we get anything from predicting a frequency spectrum of a signal as opposed to the time series at a given length of time?
What do you mean the frequency spectrum of a signal?
Like if you had some features and you tried to predict, let's say you have the frequency spectrums from the first 50 time points, and you trained a model to predict the 51st time point frequency spectrum, and you tried to do that whole prediction thing, like you tried to use from 1 to 50, predict 51, and then you used 2 to 50 plus the 51st one to predict the 52nd one, and you try to move that sliding window to predict on your prediction, but instead you're doing it for the frequency contribution.
So basically it's like you wanted to have like a time frequency plot, and based on like the previous times predict the next column of like.
And the reason I bring this up is because these frequency plots are shift invariant or phase invariant, right? Because the phase is a separate.
Yeah. Like the Fourier transform, you can get the phase from it too. But yeah.
So I don't know, maybe, but it would be interesting if there was an easy, if we were successful in.
Honestly, though, I think it's a harder program than
doing the whole frequency thing.
Yeah, then like predicting the next point.
Yeah. So if we were to like,
I think it'll be amazing if it succeeds, though.
Yeah. So going back to the original idea, if you had, this is our data, we're looking at the 51st time points here. We could generate some accurate sparse representation of this data and then somehow use it to validate whether the predicted times are like valid, right? So if we were predicting this right here, this blue line, we'd know from the sparse representation here that it's invalid because it just isn't observed. And maybe you could have some model that would try this. It would try to predict this, and you'd score it against the dictionary, and then you could reject it based on some. You could do some simulation experiment. You run some simulation where you basically run like 100 different trials of prediction with like various weights, and then whichever one matches the dictionary the best is like the children for the next generation. So right now we're mixing a couple things. We're mixing time series prediction, generative algorithm, and sparse coding. I don't know if I was clear at all with that. But so let's break it up. So like Asamu mentioned, sparse coding is when you take a signal. This can be time series, it can be an image. It's typically applied on images. And you generate a, look up sparse coding. EdCam has a bunch of good figures, but I'll just use Google or whatever. Yeah, so this one's good. Basically, sparse coding is when you take a picture and you take patches of that picture and you try to form a dictionary of elements that are explainable. And these explainable images are just patches that occur in the image. And then you can reconstruct any subsequent image based off of a linear combination of those patches. So you can see that these red blocks are patches, they're forming a dictionary, and then you can form a picture as a linear combination of those patches. Okay, that's the sparse coding part. We talked about the time series predictor. What a generative algorithm does is it basically, you can kind of think of it like as close to natural selection as possible. You start with a pool of people, you put them into the environment, whichever ones are most fit, they would survive and the other ones would die. And then the most fit individuals would, go undergo some mutations and then they would populate the next generation. So what I'm proposing is that you mix all three of these. you take a time series and you create a sparse representation, and then you predict a set of maybe like 100 predictions out into the future. So like these lines right here are 100 different predictions. Sorry, my computer is, there we go. These are 100 different predictions in the future. And then you'd use some generative algorithm by comparing these 100 predictions to the sparse coding, and whichever one scores the highest would be the children of the next generation, of the next 100. And in there, you'd want to have some random weight set to either the prediction of these 100 time series as a way to randomize which ones are predicted. Does that make sense, or am I talking gibberish? Or
No, it makes sense.
Osama, do you have any questions?
No, I think it's good.
Okay. Does anybody else have any questions? I mean, they can be simple, complex. I just kind of came up with it on the spot, but okay. So if we'd want to go along with this project, I can see Andy's typing in the chat. What applications would we use? So Andy, the thing is, all time series data, this is I think this is why Molly brought it up in the first place, is because we both realized that it's a low-hanging fruit in that all time series is the same, right? And the applications are field dependent. So like we explored stock prediction in fall term, and that is based off of, a very volatile stock moving up and down. And if you can figure that out, then you're very well able to, play the stock market and make a lot of money. I mean, in heart rate, when you're dealing with heart rate, you can kind of use that to predict whether there's some periodic arrhythmia or whether there's an anomaly in the heart rate. EEG is more high resolution, and that would allow you to kind of predict in the future if something's going to happen to the signal that would be like an artifact or an event. There's a lot of applications in time series, but studying time series in general like this might allow us to just get that low-hanging fruit, but I don't know how well it'll work. Cool. So yeah, for next week, I'd say, okay. For next week, we should explore whether this has been done before, A. B, other similar or recent papers in time series prediction. And C, we could look into the methods to kind of implement this. So maybe it'd be a good idea for us to, first, before I keep going, does anybody have any questions about this? Like I tend to ramble with my thoughts. They just kind of spew out of my head, but Okay, cool. So like I mentioned, there are like three main concepts that fit into this idea. It is the first one is like time series forecasting. That's what it's called. The second one is generative algorithm. And then the third one is sparse coding. I think it would be cool if, we could spend maybe if someone from the group wanted to take one of those topics. We have three people that just pick a topic and present it to the group. Maybe just where your interest lies. So maybe, Osamu, sparse coding, Alicia, if you wanted to talk a bit about like the time series forecasting, and then someone else could take the generative algorithm. The generative algorithm is actually very closely related to reinforcement learning as well. So if there's any, I know I just said Osamu and Alicia, but if anybody would like to take up any of those three topics, you just let me know. I think that'd be cool if we just spent like a 10-minute presentation on each of one of those, so everyone has a good idea of what's going on and how we might be able to implement it into one project. Any takers?
I can present about the time series.
Okay, cool. Osamu, would you want to do sparse coding?
Maybe. I'm not
Okay.
sure like what time, because some like this time is a prime co-op working time. So
Okay. Okay.
yeah. So maybe, yeah.
Okay. Andy, you want to do the when you said I can join regen, do you mean the generative net could you right, okay. Do you'd like to present on the evolutionary algorithm? The generative algorithm, yeah, okay. Yeah, it's like a generational, evolutional, whatever. And then yeah, so then Stefan, do you do sparse coding?
No, but I could look it up. I mean, I don't mind.
Okay. I'm just trying to think of who else. Who else is on?
I could try to do my best, but
yeah. I'm just thinking of who else besides Osamu who's close with Kim and would like to.
Maybe you can do it.
Goodness, that is a possibility. Maybe I'll communicate with Stefan and we'll put something together. I've sat in on a couple of Edward Kim's sparse lab. What's the purpose of the frequencies in general, or for what purpose, Andy? Okay, so yeah, so if we have like a time series, actually, I don't want to draw this. I'm gonna look a picture because I think people have probably done this before. So typically, like features in the time domain aren't all that helpful for a number of reasons. They're highly volatile, and it's hard to generate features based off of the time domain. Like you can get like mean, median, range, different values like that. A while ago, I think the idea started with a guy named Fourier. So if we look at like just want to get a picture. Yeah. Okay. So the idea started with Fourier, which he was some mathematician, some scientist. He's dead now, and I guess he observed that you can kind of decompose like any time series signal into composition of. That's not what you start off with that. Actually, I don't know exactly how to describe how you.
Actually, you're right. You can
Okay.
decompose any type of signal into
sines and cosines.
sinusoids. Yeah.
Yeah. But then how do you construct the frequency domain from that?
You mean like frequency and magnitude?
Yeah.
So basically, like they become like bunch of, if my understanding is correct, they become bunch of complex values, right?
Yeah,
so it's
yeah,
like
yeah.
something times cosine plus I sine theta. So you just get the magnitude of that.
Okay.
That complex vector. Yeah.
So the point of it of the FFT is to create this alternative way of encoding features, and like when you think back to like chemistry or any kind of class where you talk about frequency of a signal, it's basically how quickly it repeats itself. And so in a signal like this in the time domain, you can see that it's very, there's a high frequency, but then there's also low frequency. Like you can see that this like repeats itself. So that there's lower frequency here, but it's a lower it has less of a composition to the signal. And then the frequency domain just shows you the frequency contribution in that signal, and it's used for feature engineering. Cool. Good question. Thanks for asking that, because I obviously don't know how to explain it as well as I would like to, and I like to understand how to explain things. So that means I understand it. Cool. Awesome. So yeah, so next week I'll focus on the literature review, and usually in the research process, I've been doing this for a bit, and usually you want to kind of look in literature as soon as possible to figure out and make sure that you're not doing something that someone else has been done, and also to recognize whether this is a hot topic. We discussed that it's a hot topic for a couple of reasons, right? Yeah, I look forward to it. Does anybody have any questions or other ideas? I'd hate for these meetings to be just me monologuing.
I don't know if I'll be as active this term, but
that's okay. I know you're busy.
Yeah, but one thing that might be interesting is some project that will be actually useful for Drexel or something.
Yeah.
Like that they will want to like use,
Yeah, that's a good point.
Be awesome.
something with AI. We could do one of those automatic acceptors, automatic decliner things for like students who apply to Drexel.
Oh,
I could see us getting into some
that's
trouble.
Confidential. Yeah.
I could see us getting into some
discriminate against women.
Yeah.
Just like Amazon.
Nice, Adam. Nice, good one. Let's not do that. Okay. But yeah, that's a good suggestion, because a lot of we are like a Drexel AI, Drexel Society of Artificial Intelligence Research Interest Club or whatever. We should do something for Drexel, because we haven't done anything for Drexel this term, aside from, get their name out there.
You can sell something. Either way,
you could sell something. You're always trying to make money, Asam. I also noticed that.
I don't know. Well, money is kind of like a safety thing.
Money is a safety thing. Cool.
Yeah.
So for the rest of the group, what kind of things would you imagine we could do for Drexel? Are there any apparent user needs you see at Drexel that you could solve with machine learning, aside from deciding who gets accepted and who gets declined? Oh, Drexel, I mean, that would be an easy algorithm. You just accept everybody.
So basically I made a project for Drexel in a hackathon, and in this project we had to decide the master's degrees based on the certificates the users select. So maybe if I can share my screen, I can show you the website. And
you should have ability to do that. Yeah, good. So you were trying to predict the master's degree based off of what?
Based off the certificates that the user selects. So wait. Okay, so these are the certificates. Okay. And if you select the cybersecurity one, so it will just select this one and then this one. And when you click on generate degree, so the algorithm behind it is just based on numerical data. So for example, if I choose cybersecurity, it will give points to the Masters of Science in Data Science, and then the probability increases. So I was thinking of applying neural networks to it and looking at how we can raise the probability of a master's to be based on the certificate selected. So I mean, yeah, it's a dummy idea, but still.
How'd you do this? What do you did you do some NLP, or what did you have some graphical thing that basically tries to show display relevance between topics, or how? I don't know much about topic engineering or that.
Yeah, so it's really simple. Basically, for every certificate, so as you saw, I've selected cybersecurity. So I've given some points of that certificate to every degree. So if for data science, cybersecurity probably has 10 points. Applied science has 10 points for data science, and then cybersecurity might have 10 points for software engineering. So those two are on the top, and for the other degrees I've just kept those certificates points a bit lower than the other. So it's just simple how it works, nothing more complicated. It's just based on a point system and method decision.
Yeah, so that's what we call like an expert system when you basically give values to categories based off of what the expert or you define. There are topics in machine learning called I think the topic is like topic learning, where you try to use like natural like similarities between words or similarities between descriptions of words or in order to identify which topics are the most related to each other. So like, a baseline heuristic is an expert system like you have implemented here. But the next step would be to do some topic learning, which would be interesting, and that might not be a bad thing to kind of survey, because there's so much information out there on different websites, from the Princeton Review to like College Board to local blogs that talk about what a specific major is. But when you go to those can be so personalized to a university, that maybe it would make sense to kind of try to use machine learning to predict based off of like interests identified in certificates. I don't know, but that is a pretty cool idea. That is a pretty cool idea.
Yeah, I mean, Drexel, they hosted this hackathon because they really wanted to get this website. And I guess this is one of the ways we can help our university.
Yeah, no, that's actually a really good idea. Thanks for sharing.
Yeah, that's true.
Any other ideas? I operate in the realm of ideas, so I just spit them out.
I had oh, hey there. Can
Hi.
you guys hear me?
Do you want to introduce yourself? I think you came after we did the whole introduction thing.
Yeah, sure. Sorry about that. I've actually, I joined last quarter, but I had class during the meeting time, so I don't think I've met any of you. But I actually went to elementary school with Adam, so that's cool. Anyway, so my name is Adine Solomon, and I'm a junior studying computer science, focusing on AI and machine learning. And then I think I'm also going to swap out the intelligent systems track for some of the other legacy tracks, which is basically just a bunch of overlap. I had an interesting idea for my senior project, which is only like a little bit relevant to Drexel, but more relevant to the staff at Drexel, which is sort of like an emotion and attention analysis algorithm for participants in web conferences and maybe also classes, just so a professor can see when he's losing his students' focus, or maybe a presenter can identify when he should speed up his presentation or slow down and talk in more detail.
So I guess that would be pretty cool. What I imagine when you say that is like, how you have the emojis on iPhone. It'd be cool if in the upper right-hand corner you can kind of shift, you can change the emojis based off of what you predict the user's feeling.
Yeah,
I think that'd be really cool. Like, obviously, if someone was crying, you'd see the crying emoji. If they're laughing, you'd see the laughing emoji. That could be pretty comical, right? As a professor, I'd lose my mind.
Yeah,
but
that's funny.
That is a really good idea. And that would be extended way beyond Drexel. That is definitely far beyond Drexel. Wow, a lot of ideas. Cool. Yeah. So I guess for next, sorry.
Yeah, and one thing, this is not the idea for like those kind of stuff, but in general, I think like for how many members do we have in Drexel AI?
Oh,
it's
a lot.
Like, yeah, it's like 100, 200. Okay. Yeah. But like, I'm quite sure most of the people don't know AI, so yeah, maybe just having like introductory courses for them or learning resources for them might be like a good, just boost the actual AI people population in the group.
Yeah. That is something I noticed, because we typically have low engagement in the meetings. The most amount of engagement we had was with the conference, though, that happened 3 weeks ago. That was the most amount of engagement we've had at one time. It was for an extended period of time, so I was pretty happy about that. It's like 6 hours.
Oh, okay. Then maybe there should be more events or something.
Yeah, maybe. I think there were about 22, 23 people, participants, and the keynote speakers, and that went down to about 10 or 12 in the second day. So people definitely are interested in learning, but if we were to create resources that would teach the whole AI system, that'd be really interesting. So that is a good suggestion. So yeah, we have a lot of ideas. Just a matter of how we want to, in what order we want to do them. So
I think we should do the easiest ones first.
Yeah, maybe
yeah, the easiest one.
Yeah, maybe we should introduce like the whole machine learning and AI world first, and like maybe some like basic programming for like Python for if people are like inexperienced in that too.
Yeah. So something I did at my lab at the Children's Hospital is I would give workshops each Thursday night. I've since stopped that because I often realize it's easier. It's so interesting. If you want people to learn, you don't exactly teach them. You kind of just inspire them to teach themselves. That's kind of why I roll my eyes at whenever people say that. Oh, the professor, he's so bad. He makes you teach yourself. And I'm like, well, that's the best skill you could ever learn. So if we wanted to do some like a couple webinars while we're still on Zoom this summer, and give some demonstrations about what we do in AI, what's possible to spark some interest, and then give them resources of where they can teach themselves, I think that would be it would be pretty easy to do because we all have projects going on, and B, there's so many resources that we probably all use to learn what we know currently that extend way beyond the classroom. So maybe organizing that later in the week as an event that wouldn't be so large scale as a conference would be pretty nice.
Yeah.
Actually, we have a workshop. Sorry for interrupting you, Sam.
No, go ahead.
So yeah, we're organizing a workshop. I shared it on LinkedIn. I sent it. Yeah. So in that workshop, we're going to have intro to deep learning, machine learning, bash scripting, and it's more organized towards biological data science, but I think it would be a great tool for the beginners to get into the field of machine learning. Like and also it's free, so they can sign up. I can share it on our Slack channel.
If you send that to me again, I know you sent it to me, I can send that out as a mass message to all of Drexel AI.
Sure.
Yeah, cool. Sama, what are you gonna say? And then I have something.
Yeah, so it's a bit of a funny idea, but since we are like a group for like looking at data, I think it'll be maybe first interesting to look at the data of the participants or the actual people here. So like just collect basic data on like 173 people somehow, and then just kind of like I don't know,
a Google form, try to predict your major.
Or predict your major, or like just get
that'd be a fun project.
Just figure out what's the most kind of basic Drexel AI person, or like
that'd be interesting.
Like that.
Yeah, that might be wow, a lot of good. I should be writing these down. I'll try to remember them. I was gonna say that I guess with something we want to do for the community, we don't want to do things that are already being done. So we had this idea to do some workshop that would teach people about AI, but obviously Molly has some group that's going to be doing it at a much better capacity than we will be able to. But what might be interesting if we had some meetings, beside our Monday morning meetings, in which a person, it's beside the general body meeting, in which a person was assigned to give a presentation. An active member was assigned to give a presentation on what they're currently working on in some sort of keynote fashion. I think that would be good because it doesn't necessarily teach what Molly suggested or said they're going to do in that organization, but it introduces people to a topic that they probably have never thought about.
Yeah.
So I know Adam does the whole machine learning safety. Alicia does time series prediction. Samu, we're doing some pretty cool stuff with Moberg that we probably can't talk about, but we could probably figure something out.
And another reason I suggested that idea is because then I think we can get the general AI skill level and stuff of our current population and just target events towards them. Yeah.
I will create a whatever they're called, a Google form, and I'll send it to a chat in Slack. And then we can, I don't want to spell audience incorrectly. I'm creating a Slack name. Of course I did spell it incorrectly, okay. And then I will basically share it there. So I created general audience understanding as a Slack group, and you guys can join if you're interested. That's where I'll post the whatever Google form I came up with, and then we can tabulate the results, and we can do some sort of message to show, oh, of the people that responded, blank, 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 were, you know, interested in AI, and then that'll help us with gearing what we do towards them. So we have a lot of ideas of things we can do this term, which is good. I was worried coming into this meeting. I was like, oh, I have no idea what we're going to do, but now we got some work to do. So thanks, guys, giving us some work. Yeah, so that's it for me. I'll stick around if you have any questions. Alicia, we can connect on after this.
Okay.
You still want to talk?
Yeah.
Cool. Yeah, but thank you for joining in. We'll see you on the 29th.
See ya.
Andy's asking what is our first thing we're focusing on. So I assume that next, I'll send out that, I know we kind of evolved what we're going to talk about, but to Andy, I'll send out that general interest form. I'll send out that, that form to everybody to see what they're into, and I'll use that to decide what we're going to do next. I'll use that to decide what we'll do in the coming terms, but next week you can expect some presentations from Alicia, me, Stefan, on the projects on the research project that we'll attempt to do this term as well. Cool. Yeah, thanks for asking. I almost forgot what we were going to do. Cool. Okay, so people are still here. What's going on? Do you have any questions? You're leaving? Okay.
Oh yeah, I'm gonna head out.
Okay, see ya.
Thanks so much.
You got it.
Wait, do we have anything more to discuss?
I think we're okay.
All right, cool.
Oh, actually, can you please? We are still discussing our individual topics, right? Yeah, next term, next week. Yeah. Adam, could you actually do you have availability to create events yet?
I haven't checked that in a while. Let me look it up.
Yeah. Could you check and figure it out, and then put our weekly GBMs up there?
Yeah. If I can do that, I will do it.
Okay. And if you have any questions, just ask it, because he's done it before and he did it in the past. And maybe ask. Yeah, I don't know. I don't know how to do it yet, but I can do it from my end. But I'd rather have you do it, so that teamwork.
Okay. I'm in the Action Center. I'm going to Drexel Society of Artificial Intelligence. Let's see if it'll finally let me do it. It appears not.
Okay.
But I'll ask Git and see if he can either help me, or we'll see about getting permission.
There was an email. It was an email that Alicia sent a while ago. I forget if you were CC'd on it, but we should follow up with that person.
Okay. Let me check my email. Drexel. Alicia, it was Drexel email, right?
Yeah. I'm not too sure if I CC'd you, to be honest. I think I only CC'd Ethan.
Yeah, I don't think you CC'd me.
I can just forward the email to you.
Yeah, if you can find it.
Yeah.
Cool.
Okay, yeah, so I'll follow up with them.
Yeah, what's your email, Adam? Just type in the chat for me.
Yeah, sure.
Very cool. Yeah, I'll do that right after this.
Thanks.
Cool. All right. I'm gonna stick around and talk to Alicia.
All right, cool.
Cool. See you next week.
Next
If
week.
you have nothing else. Okay. Okay.